So for those of you just joining us, we showed how yesterday, most of you, in this class at least, said, hey, first derivative, second derivative, it's awful, it's painful, but let's do it. You have gotten to a cubic polynomial that you're like, how do I factor? The AP is not going to expect you to do all this for a multiple choice question. An alternate method would have been long division. Let's take two derivatives and let's get common denominators and let's simplify and factor. The AP would not expect you to factor. I'm almost positive a third degree polynomial on the test. The alternate way would have been to take the numerator or to take this function set equal to 0 and solve a much quicker way with a cubed root. But then we just got to a pip, and as we all know, inflection points, actual inflection points need sign changes. So when you guys do a sign chart of the second derivative, plugging into the second derivative, hopefully the easier form of the second derivative, which was up here, sure, why not, before 1 and after 1, plugging in 0 would have gotten me with a negative over a negative, right? Positive? You guys double check? That's a negative 8, 16, that's a negative and a negative. Yeah. And if I plugged in something like 4, that's all positive. Well, 4, 4, 4. Let's plug in 0 again. 0 is a negative cube is a negative, and that's a negative and a negative. That's a negative cube is a negative, positive. Did anybody find a sign change? Am I just being silly again? My smartboard doesn't even work. It does, it does. I'm just being a Debbie Downer. Oh, so this one I have a negative and a positive, but I'm doing it from 2. Oh, I have another critical number. What about 2? Aha! Struggle. Guys, even though 1 was my only pip, what else do I have to put in a sign chart? Oh, bummer. What's my critical number? My vertical asymptote. What about my 2, my domain problem, right? So what about 1.5? What about 1.5? 1.5 minus 2 would still be a negative, but this time it'd be a negative 1/2 cubed is a negative 1/8. All of a sudden he wins, not him. So that's going to be a positive over a negative, which is a negative. Oof. Oh, there are 2 points of inflection. Are there 2 or is there only 1? There's only 1 because even though, yes, there is a change in concavity from here to here and here to here, isn't this one at a vertical asymptote, which is a domain problem which doesn't even exist as a point? So the only inflection point is at 1, and that point is going to be 1 comma, where do I plug in to finish my point? The original. Got him. So we have 1 plus 1 is 2, minus 2 is 0, minus 1, negative 1 over negative 1. Is that a positive one? I have it covered up. No? Double check. 1 minus 1, sorry, 1 plus 1 is 2, 2 minus 2 is 0, negative 1 over 1 minus 2, right? Negative 1. Negative 1 over negative 1 is positive 1. I think I'm right. If we were to use our words, there is a point of inflection at this point because the second derivative of 1 equals 0 and the sign of the second derivative changes at that. Dun, 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 dun. Points of inflection. Good?
Is this going to be a question on ourselves?
This exact one? Oh, I hope not. Well, John, let's just say, wait. You won't have time to do it the long way. But the long division way, pause. We're trying to think of problem-solving techniques, and on the AP, what derivative were we supposed to find last year? The 23rd, 7th, 8th, 9th, were you literally supposed to find 23, 5, 7, 9 derivatives? No. If you're taking an exorbitant amount of time and doing an exorbitant amount of work on a multiple choice, you're doing it the wrong way that they intended. So, what can you do whenever you have a polynomial that's nasty and you have to do relative extrema or points of inflection? What could you do? Long division. And with long division, what could you do? Take derivatives of him And once you take derivatives of him, what could you do? Go looking for critical numbers and endpoints, and we try to avoid foiling if at all possible, right? Does that make sense, strategy-wise? Okay. To that end, wait a minute, what section are we in right now? Graphing f prime, f double prime with a graph of f. Maybe it's not relative extrema. Am I crazy? I don't know why I wrote that down. Oh, relative extrema is where it starts. Oh well, points of inflection is what we were just talking about. But why did I not have homework due today? Yeah. What do you guys see over here? It's a graph, right?
Yeah.
And guess who it's a graph of? Of a derivative. And guess what we have to be careful of when given graphs of derivatives? How we read it. Oh, struggle. Hey, are some of you guys doing test corrections or just have done test corrections on a test where you had to look at a graph and try to find characteristics about motion? I was reading your test corrections last night trying to get you points back on chapter 3, and a lot of you were like, oh, I didn't realize when you read the graph you need to. Oh, awkward. Ready, set. In your notes or in your workspace, I don't really care. You as a group, can you tackle this graph of the derivative and make sure everyone in your group knows how to read it correctly? How to read it, how to analyze it, how to think through it correctly. In your workspace or in your notes, I don't frankly care. We're going to go just do a quick recap of everything with graph clues, but this is why I took another day. Graphs. AP loves them. Can we too? Draw the graph, or else you can't study from it later. Draw the graph, or else you can't study from it later. What's a graph?
I'm going to watch the video.
Contribute, don't detract.
Zero, open bracket, at 0, or no, I mean -4 to -2, open bracket, because at -2 equals 0, and that means it's, hello, are you high? It's -4. F is increasing when f prime is greater than 0. At -2, it's not greater than 0. It's equal to 0, which means that the slope of the derivative, which means -4 to -2, open bracket, and then -2 to 1, open bracket, and that's it.
So that's, if you write it down,
You can.
wait, so
That's when the second
negative
Remember, it's not just your understanding, but also your group's understanding.
Double prime is greater than 0, which is when prime is increasing. So it's increasing from -2 open bracket to
What is the concept of F concave?
yes. I was thinking about 0 open bracket and 3 open bracket to 4 close.
So I'm hearing people talk about open and closed, especially for this example. That's a very good thing to be talking about.
So is it
Precisely.
So open like from -2
so when the
Why is it
when
open
F is
bracket?
concave, that means the derivative
You tell me
is increasing.
points.
So just find the place where
Figures.
F prime is increasing.
Because it's not increasing at 0, it's still at 0, it's flat. Does that make sense? The slope is 0, it's not a positive slope. That means it's not increasing.
So whenever F prime is positive, F will be constantly above, but F prime would be.
That's
Like
right.
a slope of
3
F prime.
open bracket to 4 close
So you have to
bracket.
find the parts where the graph
That's right.
positive.
At which x coordinate? That's at local extrema. That's when F prime equals 0, which is at
Oh, the first one is just when
-2
prime is positive.
and
It
1.
doesn't have to be increasing or decreasing.
For A, it's only looking at the y
What are
value.
the x coordinates of all inflection points of the graph of F prime? Oh my, wait, is that an F prime?
3 or 4, right?
Yeah.
That's an F prime.
Because on the graph,
So that means when all
you know what?
when F triple prime equals 0, then there's a
Is it open bracket?
pip pip hooray.
It's open bracket.
For -2, right?
How would you draw the
3 is just the zeros.
I think it's open bracket
I'm
3,
offended.
comma 4, close.
Yeah.
That's exactly right. Or the second derivative of F prime.
So,
The third derivative. But the second derivative. X coordinates of all
F has a local
inflections. Pips
extrema.
are when F double prime equals 0.
So
F
you
double
need to
prime
do the
equals
Yeah,
line.
0.
it's a 1.
I think it's.
It's when
I think one is
concavity
one.
changes for this graph we're looking at
Yeah.
here.
I think that one.
No, that's when, what's it called?
Because for 4,
That's
I
when
think it's either like-
decreasing, increasing
Wait,
changes.
That's the line.
Concavity
Oh.
changes when it goes from Johnny Whoops to Johnny Whoops.
Oh, we're going back to Johnny Whoops, huh?
X
So that could be like, around -1, yeet. But
Oh,
no.
Oh, I got it.
Throwing the
It's like-
8
it's
and
switching.
Because
Okay, yeah.
from
Yeah.
negative coordinate, it's still going up, and then it goes, down.
No, but that small line is like.
Okay, yeah. It took me like
No, it's not
negative
part
1 to
of it.
negative 1.
Well, I don't know, because, like, I can't really tell. But all I know is something that you can bank on, no matter what you know in life, no matter where you are, you can bank on the fact
We're
that
still
there
working.
is a pip
Oh, we're still working?
F double prime
X equals 0.
of F prime. So that's where concavity changes. So when
That's a possible graph.
so maybe -1
It's
and
like the hard.
Those are pips.
2.
But then they actually occur.
You said 0.
Yeah, but it actually.
Because that's like the third point. I don't know if
Yeah,
negative.
I mean, sideways.
No, it doesn't count.
It means that sideways is
So it's gonna stay up.
Wait, but it's inflection points?
And then if you reverse derivative.
Sketch a possible graph of F on the
When the second
array. So
Hey, you can inflection points. Does negative 2 count?
what? Kevin, it wants inflection points of F
So
prime.
local extremes are height different, right?
Yeah, I thought it was that point.
Yeah.
It says
No, but we're
Oh my gosh, I think it's the question mark.
Oh.
Changes from decreasing.
You're right.
Dude, my new version.
David, we wasted our time.
When the first derivative changes.
That looks like F
I want to
prime.
sketch these.
That would have been an interesting question though, right?
Wait.
It
Oh,
is.
so it's negative
So
2
now
and
it's-
3?
Just
I'm so
Yeah.
bad at
when
this.
F
I
double
can draw
prime
faces,
is
but not
0.
graphs. I mean, negative.
The third
F double
one.
prime is
Yeah,
0.
uh-huh.
So,
Is the mins and maxes of F
If
prime.
When it's a slope
Because,
of,
yeah, when F prime, or no, when F double prime equals 0, then that means F prime will have a min
So
and a
negative 2,
max.
0.
So that's -2, 0, and 3. Oh, Kevin starts writing down. Great. So he said
I'm trying to draw the graph of it. I want to. Okay.
But that's when it changes from increasing to decreasing or vice versa. So,
You just said
-2.
Ryan is talking so loud, Christina can't.
I know. I was thinking always.
-2, it stays increasing.
Keeps on talking loud.
Wait, no. When f double prime
I don't know how to
changes
draw
from
this.
increasing
Sorry.
to
So F
decreasing.
is always increasing when it's on the positive.
So when does f double prime change from
Wait,
increasing to
positive.
decreasing?
Because
Yeah, increases.
When f double prime is increasing,
-2 is concave
then
up.
And then
f prime
concave
is.
Like this.
Let's start playing.
F double prime.
No,
Graph of F is
Because F prime.
when f double prime is increasing, then
Yeah.
f prime is increasing.
That's when it changes.
So when f prime changes from increasing to decreasing, at the inflection
Yeah,
point,
when it
-2 and 0 and 3. So there it changes from decreasing
Inflection
to
points
increasing.
are
So
when
that's an inflection
No,
that's
point.
just a little like
-2.
the
When
bottom
F
of
switches
like
concavity.
use of it.
Yeah, it's
Wait,
when
That's
the.
when.
Yes.
I can't
So
do it.
when
So
You
the
can do
first
E.
derivative has like.
Yeah, yeah. Those are inflection points.
Oh, okay, I got
Those
it.
are max and the min.
Then
And then
Oh my
okay,
God.
graphing, big brain.
I was
Oh, dang.
Okay.
I'm so
Yeah,
off.
that means that.
So why
F
is it close to
is
negative
going
for
positive.
I was still working out D.
No, I'm on A.
Yeah, but concavity.
Because it doesn't cross.
Is it?
It
Is
doesn't-
it shaped like?
Well, I guess my IQ just decreased.
So, oh, this D is -2.
It's not negative.
Oh, on this one.
Yeah.
No.
I know, but.
Yeah, if it's concave down.
What? No. What happened, Kevin? You want to share something with the class? Show and tell?
Okay.
Show and tell?
Wait.
No?
I got confused.
There's a lot of things we can do with robotic phenomenon.
And double prime change.
We have to do, what's it called?
Which
Undercover
when
boss.
F prime
Okay.
increases.
What's it called? Wife swap or whatever? Leader swap? Yeah, there's an HGTV show called Wife Swap. Something like that. In two families, they swap wives. One is like usually super strict, one is usually super and then they get culture shock.
You see the one where, like, the world's strictest parents?
Yeah, I think I know what you're talking
Like,
about.
what's the British
The extra.
Oh, no, mine was in the deep south.
I think mine is
I don't know if it was on HGTV or whatever.
It's either HGTV or TLC.
Yeah, it's one of those.
Nope, those are critical numbers.
We're both thinking the same thing
Kids
though.
are where the F double
Wait.
prime equals 0, isn't it? And
I don't
change
know.
that.
No, when my mom's gone,
Oh, we got D right. Double, triple, quadruple checking.
Oh, I don't know.
Oh, I understand what I did wrong now.
No, we did.
Only 1% percent of the population will get A correct.
Oh, is there multiple ways to
No,
do
I
this?
was like eight, like I checked that.
Yeah, you're not for the 1%.
Like, I thought you had like four.
No, I said negative.
I'm gonna say 790 and
Negative.
negative 2.
Unless we're the top one of the top one.
Okay, so we're good.
I'm pretty sure I'll people get results.
Right.
It's not the top one, it's not the top one. Who said that? It's like, that is not 1%. It's 99%.
Well, yeah, that's still a lot of people.
Yeah.
If you take a room with 100 people, okay, on my
You guys agree?
Yeah.
Why does my function need to start, or my, original function, right? Why does my function need to start increasing yet concave down? Why does my function start increasing but concave down?
F double prime is negative.
Because f prime's slope is negative, but what is f prime? Positive. So my function is increasing because f prime is positive, and yet it's concave down because f double prime, or the slope of f, is negative, right? So remember, if this is an f prime graph, these are my y values. You could technically think about f with area under the curve, but we're not really there yet. And then f double prime would be slopes, true? And then why does my function keep increasing but now concave up? Wait, why did it level off? Because it hit 0 at -2, right? But why did it not turn into a maximum? Because I didn't pass the line. So my function's increasing, leveling off, and then increasing some more. But increasing in a way that my second derivative is now positive because f prime is increasing, or the slopes of f prime are positive. So f double prime is positive, hence concave up until 0. Why is everything changing right around 0? I use 0 as a best guess. Because what happens at 0? F prime levels off, which means f double prime is 0, and then what does f double prime do? Because f prime starts decreasing. Changes. Yeah, so therefore concave up has to change to concave down. Still increasing, because my derivative is still positive until at 1. Then what did my derivative change to? My derivative changes from positive at 1 to negative. Can't say decreasing. I have to say negative. My derivative changes from positive to negative, which means my function changes from increasing to decreasing, which is why I have a relative maximum. Now, guys, this whole thing could be shifted up or down. I don't know where this happens. I just know it happens somewhere. I don't know where exactly it happens because it didn't give me an initial point, so I don't know where to start from. But I do know there needs to be a relative maximum at 1. My function changes from increasing to decreasing, so my derivative changes from above to below. My slopes are still, or my f prime is still decreasing, so I still have a concave down portion this whole time. Decreasing, concave down, up until 3. What changes at 3? Concavity changes because my f prime changes from decreasing to increasing. My f double prime changes from negative to positive, so concave down to concave up. Why did I put closed intervals for increasing at -4? Because what is f prime at -4? Positive, 0, or negative? Positive. At -4, this is not a critical number. This is not a 0. This is not something to be excluded with intervals. This is something that must be included because f prime of -4 is positive. So at -4 it needs to be included for increasing. Why did I close my interval for at 4 here? What's the slope at 4? Concave up. My slope at 4 is concave up, so you need to include it because at 4, yes, I know it's leveled off. Yes, f prime is 0, but f double prime is included at 4. That is still a part of a concave up graph. To be honest, concave up is probably going to continue on if we were to keep going. Woo! How did we do? Who made a mistake on the intervals? Open or closing them? Just open or closing them. Okay. How many of you guys made a mistake on the actual numbers in the interval for the different characteristics? Okay. How many of you guys made a mistake on the sketching of the graph?
1%.
Do we have questions?
Why okay. So
Joe 2.0 either way.
So on A, why isn't the interval from -4 to -2 and from -2 to 1?
Well, the reason I combined them, because I started to do it that way, because usually we split up at zeros. But the more questions I see, the more I see them just talking about this being strictly increasing the entire time, so I decided to make it one full interval just to bring up that topic if you guys asked. Because that 0 doesn't technically stop the increase. It's a momentary sliver of time in between. Like if you were to go infinitesimally, I don't know. I wouldn't necessarily say it's stopping. I've seen them talk about this function strictly increasing.
So if we put like the
If you split it up, you would have been just fine. Yeah, you would have been just fine. They wouldn't have taken this up. But I do believe I have seen, and we can keep an eye out for it, but I'm pretty sure that I've been seeing them talking about an interval like this that's strictly increasing. Now, if there had been a vertical asymptote, a discontinuity, something to actually break the graph, that would be different, and we would have to exclude it. Does that make sense? But this one, it's not a domain problem. It's not a discontinuity. It's just a 0 in between increasing to increasing. Kind of like how we say that x cubed is strictly increasing or tangent is strictly increasing, even though there are zeros. But yeah, let's keep an eye open for that if you guys don't mind to see. I'm pretty sure that they just have the full interval. We can keep them in. Is that good? Anything else? Okay. So, some of you don't need this other page at all, but I just wanted to go ahead and do a quick summary of graphing characteristics. If we have a graph of f, original versus derivative versus second derivative, if we have graphs, because this is a section where they're talking about looking at graphs, originals, first derivative, second derivative. If we have an original graph, we can look for that functions, HTLs, VTLs, DNEs, look for the domain restrictions, look for the leveling off points, and look for the vertical tangent lines. We can think about the signs of the slopes pointing to f prime. We can think about the concavity pointing to the signs of f double prime, which is also the increasing, decreasing of f prime. If we're looking at a graph of f prime, we can look at the zeros and the DNEs, including like vertical asymptotes, poles, etc. We can look at the zeros and the DNEs of f primes as the critical numbers of f. We can look at the signs of the y values above or below. If that helps, we could go ahead and do the sign of the values. Remember, the values are the above and the below the axis, as indicating when f is increasing or decreasing. Those are the signs of the slope or the behavior of f prime as pointing to f double prime, which points to the concavity of f. And if you have a graph of f double prime, you don't see that very often, but if they give you a graph of f double prime, look at the zeros and DNEs of f double prime. Think of the pips of f. Look at the signs of the y values, the aboves and the belows, as the signs of f double prime, which tells about the concavity of f and the increase and decreasing of f prime. Sign change would point to a point of inflection. Points of inflection on an f prime are the sign changes of slopes. For a point of inflection on an f double prime graph, sign change of y values. Now there are times where you're allowed to use your calculator and they ask you about a point of inflection. There are times you're allowed to use your calculator and they ask you for the values of the point of inflection. Now wait a minute, no, we just had that horrible problem yesterday where I was skipping steps trying to get it done and save space and not just use like tons of pages on the notebook file. And it took us so long and it was so brutal, and I said this would be a non-calculator question. True, but what if they gave it to you as a calculator question? Looking at all of these things, characteristics of graphs, of f and f prime and f double prime. What if that nasty problem was a calculator question? Could you have graphed the original function and found the point of inflection from the calculator? From the graph of the original? Is there any feature in your calculator that says, oh, don't worry, point of inflection, here it is? No, there's maximums, minimums, intercepts, values, zeros, but there are no points of inflection. So what if you were allowed to use your calculator? How could we have found the point of inflection? If you guys finish writing this page, calculator's out. I want you to go back to that example from yesterday, the original f of x equals, and ponder. What is the least amount of work, right? Calculator questions, how to use the tool properly. What is the least amount of work that we could have used our calculator to find definitively? Because I know this one was nice. It was +1. Maybe you could have eyeballed and guessed it from the graph. But no, we're not about guessing. And we know they give us enough decimals on calculator problems that guessing doesn't cut it. What would you have had to do? How much of that work would you have had to do to use your calculator to find for you that the point of inflection was at 1? Ready, set, go. Calculator out. The big, nasty problem from yesterday, that big old rational function, the cubic. How could you use your calculator to find that point of inflection? And just a hint, you could not have done it. There is no feature from the original function. I'm going to play with mine over here too. I can't show you what I'm doing. That's no fun. Oh, I hear some unprofitable conversation. We already got our calculator to show us the point of inflection, definitively solving it for us, not just like eyeballing. Because eyeballing, guys, well, let me show you the eyeballing. I mean, I can do eyeballing. Let me go ahead and unfreeze the screen. Eyeballing, I know it's not super gorgeous or pretty or whatever. Let's see. Can I get it up here a little bit more? Let me get rid of all this marking. If I was just to graph the original function, right? We're talking about our notes. We're talking about this little dude right here where we had this function. Find the point of inflection, right? We could have looked at our calculator. As we looked at our calculator, oh, look, concave up and then concave down. I think it happened somewhere in here. But where? I know we know the answer is 1 because we solved it, but couldn't it have been at 0.5? Couldn't it have been at 0.6? Couldn't it have been at 0.7 or 0.493? Right? Now, I also see, oh, there's a vertical asymptote. Like, yeah, concave down and concave up, but that's not a point. Forget that vertical asymptote. Let's go looking for this guy. There's one point of inflection right in here. Did this function cut it up here? No. There is no snazzy, oh, point of inflection, here you go. No, it's not there. So why do I have, or what do I have right below him? The derivative. And the derivative that, once again, using long division and taking the derivative was a lot faster than this quotient rule, right? But even if I had done the quotient rule just once, I could have thrown that into the calculator. Why am I saying, or why am I at least thinking that the derivative is all that I really need? If I look at the graph, I was going to type. Anyway, there you go. If I look at the graph of the derivative, why is that all that I really need? How do you find, you don't need to find the second derivative at all if you have your calculator. If I have the graph of the first derivative, how do I find a point of inflection? Sign change of the slopes, aka find the max or min. Just like we did in the example just a second ago, right? All the maxes and mins were points of inflection. So can my calculator find a max? Yes. And I can say, hey, a max or min of my function will be my point of inflection. Baha! I can use u. But I can't use u of the original function. I can only use u of the derivative function. Now, could we have found the second derivative? And could we have found the 0 of the second derivative where the signs change from above and below? Yes. But what would you have had to do? The second derivative. Ew, gross. What do you still have to do? The first derivative, but it would have saved time. So could they give this to you as a calculator question and you still have to do some math in order to solve it? Yes, there is no point of inflection feature on your calculator. Is that kind of cool? Like a trick that we could use if this was a calculator question?
Yeah.
Yes. Oh, hey, we're done? Okay, so ready, set. What would you guys do with this guy? P.S. Homework due on Monday. Let's just work together as a class. I don't need to do groups anymore, do we?
No.
What is this a graph of? Position. You're welcome, physics people. So, a particle moving along a line. At approximately what time is the particles? I know, in physics, you guys don't get to do parametric. You can't do two-dimensional. We get to at the end of the year. But you guys are doing rectilinear, or you did do rectilinear motion just like us. So it's moving along a line. At approximately what time is the particle's velocity 0? Oh, this is a position graph. All we have to think about is when the slope is 0, right? So how about at 0, and how about at approximately, I don't know, is it this one? Yeah. 4, sure. So how about at 0, how about at 4, how about at, I don't think so, right? I don't think that's flat. Oh, that one's flat. 12? And then, yeah, that's flat. 16. Okay, what else are they asking for? Second derivative. Ooh, 8? How'd Lorenzo get that?
No, I said
Oh, I was going to say, hopefully not 8, because that doesn't look right. I don't know what to say then. Okay, we got those. Hold on, Christina said it. Second derivative equals 0. Second derivative will equal 0 if the derivative has a max or a min, right? If the derivative has a max or a min, hold on. Okay, so derivative is getting higher, 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 lower, lower, lower. Oh, there was a max in there somewhere. Where was it? Yeah, sure, 1.52. They said approximately, that's okay. At a point of inflection. Oh, inflection. Approximately. Lower, 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 lower. Approximately. Ooh, concave up to concave down. What do you guys think? Kirsch? Maybe 6?
Sure.
Look, it's concave down and then it's concave up, right? I see concave up. And then it's, it's concave down again. Ah! Concave up to concave down. Yeah, 8-ish maybe? And then we have concave down, concave down, concave down. Oh! And then, I don't know, 10.5-ish maybe? And then concave up, concave up. Up, 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 up. I don't know. Can we just go there? Yeah, sure. 50, 40. Okay, but pause. Is an AP question going to be satisfied with approximately? No. So they're going to give us like actual points and actual locations, but do you see how the points of inflection are when the acceleration is 0 and the velocity equals 0 are the maximums and minimums? Are we going to be connecting ideas of relative extrema and points of inflection with application problems and with graphs of first derivatives and maybe original functions and maybe second derivatives? Now, guys, theoretically, we were supposed to, I think, peak at 5.4 today, but it's okay. Because actually on our calendar, I always had us taking 2 days on 5.3 anyway. Google Classroom just kind of had the homework due earlier at one point, but homework is not due until Monday. We're going to go to optimization on Monday. Optimization. Oh, last year it was so nasty. But wait, wasn't the idea just fine? Oh, so just practice and homework on maximums and minimums from graphs, from tables, from words, from functions, and then we can go ahead and tackle optimization where, well, sometimes we just have to use some, problem-solving clues to help us get there. Am I totally off? No, I'm not. We're like almost done. We have like 40 seconds. I'm going to stop talking. I'm annoyed with my own voice. You guys good?
Yeah.
Happy Friday. Happy end of section 5.3.
Your voice.
Happy pepperoni day. Can you tell my voice is tired though? It's just,
That's okay, I missed you.
it was squeaking, it was gravelly.
Ew.